Okay, problem 11 asks you to construct a graph for y forples when x doubles. I'm not going to say anything, I'm just going to construct this. And it should be self-explanatory what I'm doing. Okay, I don't think I positioned this point very accurately. This would probably be somewhat lower, but again, we don't want it to be perfect because then we won't get to see the errors. Okay, there's an attempt at making the graph. Now, we're asked to, first of all, show that if y equals ax squared, and it's asserted that this does fit this graph, then if x1 and x2 are 2 points on the graph, and I labeled that x2, let me fix that. Not only fixed it, but I made it a different color. X1, then if x2 is double x1, then the resulting y values, which we would call y1 and y2, have the characteristic that y2 over y1 equals 4. Question mark. Okay, how do we do that? Well, first of all, y1 equals a x1 squared, y2 equals a x2 squared. So y2 over y1 equals a x1 squared over a x2 squared. Well, of course, that's equal to, and I got my subscripts wrong there. Let me fix it. Okay, now it's right because, of course, y2 is a x2 squared. That goes here. y1 is a x1 squared. That goes here. And we divide. Well, let's use the fact that x2 equals 2x1. So that's going to be a times 2x1 squared divided by a x1 squared. The a's divide out. 2x1 quantity squared is 2 squared x1 squared over x1 squared equals just plain old 2 squared, which is 4. Okay, since x1 squared divided by x1 squared gives us 1, so we have 2 squared times 1, which is just 2 squared, and of course that is 4. So this shows that if x doubles, y forples. Okay, y2 is 4 times as great as y1, meaning y increases by a factor of 4. Okay, now we're asked to pick a point on the graph. We can make that any point, and it's best to choose a point, even if you're not instructed to do so, that doesn't match one of the points you used in constructing the graph, and say that this point is 314. And then we're asked to estimate we're asked, I'm sorry, had to look at the problem. We're asked to scale the graph accordingly, which is a natural process. We could have gone directly to estimating. That would have required that we scale the graph. Scaling the graph, this has to be 3, this has to be 14. So if this is 3, then I guess 1 is about here, 2 about here. Looks like I've got 1 a little bit too big. If this is 14, then 10 is going to be, I'd say, about here, which means that 5 should be right around here. And of course, we'd have 1, 2, 3, 4, 5 should actually be somewhat lower than that. Looks like actually Y1 is pretty close to 5, maybe a little less. And Y2 is plausibly about 4 times that, around 20. Looks to maybe a little low, around 18 or so. Okay, well, we've got some sort of a scale on this graph, and we can extend the scale this way and this way if it turns out that we need to. Now we want to estimate the value of y when x equals 2, and again when x equals 5. Okay, so we are going to need to extend this scale out to 4 and 5. And we're probably going to need to project 5 up here, so we're probably going to need to go to 20, which does appear to be around here according to the way I located 10, and then 30, and we can go a similar distance to about 40. And it does look like when x equals 5, we get y pretty close to 40. When x is 2, I believe that was the other, coordinate, we project over. It looks like 6 or 7, so I'll say maybe 7. When x equals 2, y equals 7, so this point here would be 2, 7. And this is the point that we used as a basis for scaling the graph. Now we got the points 2, 7, and 5, 40. Okay, our function is y equals ax squared, and now we know y is 14 when x equals 3. That comes from the point 3, 14, from the premise that the point 3, 14 lies on our graph. So what? Well, we plug in y equals 14 and x equals 3. We get 14 equals a times 3 squared, which means 14 equals 9a, so that a is 14 ninths. And our function then is y equals 14 ninths x squared. Now we're asked to find the values of y when x is 2 and when x is 5 and compare with our estimates. So let's see. If x is 2, then y is going to be 14 ninths times 2 squared. 2 squared is 4. 4 times 14 is 56. That'd be 56 ninths. That's about 4.2. Well, we didn't do that great, did we? Okay, we estimated 7 from the graph. Okay, well, we're not going to be able to do a freehand graph and get really accurate estimates. But let's see now what we get if x equals 5. See if we do any better. We get 14 ninths times 5 squared. That's going to be 14 ninths times 25. And we are going to do a little better. We're going to get up pretty close to 40 here. Okay, well, 5 squared is 25. 25 times 14 is 350 over 9. So that's 38.2 approximately, if I did my arithmetic correctly, and I kind of think I did. Okay, so this estimate is pretty good. This estimate wasn't so hot. But also remember my 1 was a little big, which means that my 2 was probably a little too far over, should have been a little over further this way. Of course, that would affect my 5 also, but not by, proportionally not by as much. So there are flaws in the graph, but we seem to have a reasonable curve for the forpling graph, and we seem to have reasonable confirmation that the forpling graph is the graph y equals ax squared. And of course we have other techniques for proving that it must be so.